NEC Section 312.8 addresses the rules for splicing wires within electrical panels and junction boxes. It's important to understand what the NEC permits and what it restricts to ensure safe and compliant electrical installations. While the NEC allows splicing in junction boxes or panels, it's critical to use approved splicing devices. Wire nuts, specifically, are generally not considered an approved splicing method according to the NEC. NEC Section 312.8 focuses on the number of conductors allowed in an outlet box. Boxes must not contain more than a total number of conductors depending on their size. For example, 18 American wire gauge or smaller conductors are allowed up to a certain limit. Also, 12 American wire gauge or smaller conductors have a maximum limit. It is crucial to include any grounding conductors required by Section 250.146a, b, or c when calculating the total number of conductors. Alternatively, the box may contain a limited number of 10 American wire gauge or smaller conductors, again considering any necessary grounding conductors per Section 250.146a, b, or c, provided the box has a volume of at least 2 cubic inches. Junction boxes, with the exception of those permitted in Section 410.21, and all outlet boxes must adhere to the requirements outlined in Table 314.16a. This table provides specific guidelines for the number of conductors allowed based on the box size and type. The NEC explicitly states that splices and taps should only be made in junction boxes, unless there are specific exceptions permitted elsewhere in the code. This restriction is in place to maintain safety and ensure that splices are properly contained and protected. Section 300.15 of the NEC defines what constitutes an approved method or device. An approved item is acceptable to the authority having jurisdiction, which is the local electrical inspector or governing body responsible for enforcing the NEC. Approved devices and methods are also listed or labeled by a qualified testing agency, such as underwriters, laboratories, or Intertech. These agencies evaluate products to ensure they meet safety standards and performance requirements. Finally, an approved item is generally accepted as providing a level of quality consistent with the latest nationally recognized standards. This means that the device or method should be in line with industry best practices and proven to be reliable and safe. To summarize, splicing is permitted in electrical panels and junction boxes under specific conditions as detailed in NEC Section 312.8. However, the use of wire nuts as a splicing device is generally not considered an approved method. Installers must use splicing methods and devices that are acceptable to the authority having jurisdiction, listed by a qualified testing agency, and consistent with nationally recognized standards. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information. It is important to understand the conductor fill requirements for boxes as detailed in NEC 314.16a. The NEC dictates the maximum number of conductors permitted in a box based on its size to prevent overheating and ensure safe connections. When working with electrical systems, safety is paramount. Always de-energize circuits before working on them, use appropriate personal protective equipment, and consult with a qualified electrician if you have any doubts or questions. The NEC is a comprehensive set of guidelines designed to protect people and property from electrical hazards. Adhering to its requirements is essential for ensuring safe and reliable electrical installations. Remember that local codes and regulations may vary from the NEC, so it's crucial to check with your local authority having jurisdiction to ensure compliance with all applicable requirements. In addition to conductor fill, the NEC also addresses other important aspects of box installations, such as the proper support and securing of boxes. Boxes must be securely mounted to prevent them from being damaged or dislodged. The NEC also specifies the types of boxes that are permitted for different applications. For example, some boxes are designed for use in dry locations, while others are suitable for wet or damp locations. Always select the appropriate type of box for the environment in which it will be installed. When making splices in junction boxes, it's essential to use approved splicing methods and devices. Wire connectors, such as crimp connectors or twist-on connectors, must be properly sized for the conductors being joined. The connections must be tight and secure to prevent loose connections, which can cause overheating and electrical fires. It's also important to properly insulate all splices to prevent accidental contact with other conductors or grounded surfaces. Use electrical tape or heat shrink tubing to insulate the splices, ensuring that all exposed metal is completely covered. The NEC also requires that junction boxes be accessible. This means that the boxes must be located in a place where they can be easily accessed for inspection, maintenance, or repairs. Junction boxes should not be concealed behind walls, ceilings, or other obstructions. If a junction box must be located in an inaccessible area, it must be specifically approved for that application. Proper grounding is another critical aspect of electrical safety. The NEC requires that all electrical equipment be properly grounded to provide a safe path for fault current to flow back to the source. This helps to prevent electrical shock and reduce the risk of fire. Grounding conductors must be properly sized and connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete-encased electrode. The NEC provides detailed requirements for grounding in Article 250. Overcurrent protection is another essential safety feature of electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overload and short circuits. These devices will automatically interrupt the flow of current if it exceeds a safe level. It's important to select the proper size overcurrent protection device for the circuit being protected. The NEC provides guidelines for selecting overcurrent protection devices in Article 240. Wiring methods are also addressed in the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. Common wiring methods include non-metallic sheath cable, armored cable, and electrical metallic tubing. Each wiring method has its own set of requirements for installation and support. The NEC provides detailed information on wiring methods in Chapter 3. Electrical installations must be inspected by a qualified electrical inspector to ensure compliance with the NEC and local codes. Electrical inspectors are responsible for verifying that electrical work is performed safely and correctly. They will typically inspect the wiring, grounding, overcurrent protection, and other aspects of the electrical system. If the electrical work meets the requirements of the NEC, the inspector will issue an approval. Remember that the NEC is a complex document, and it's essential to consult with a qualified electrician if you have any questions or concerns about electrical installations. A qualified electrician has the knowledge and experience to ensure that electrical work is performed safely and correctly. Always prioritize safety when working with electricity. To energize circuits before working on them, use appropriate personal protective equipment, and consult with a qualified electrician if you have any doubts or questions. Understanding and following the NEC guidelines is crucial for ensuring safe and compliant electrical installations. This not only protects people and property from electrical hazards but also ensures the long-term reliability of the electrical system. From conductor fill requirements to proper grounding techniques, each aspect of the NEC plays a vital role in creating a safe and functional electrical environment. By adhering to these guidelines and seeking professional assistance when needed, one can contribute to a safer and more reliable electrical infrastructure.